Hi, welcome to ChemTube channel. I'm Jacob Wong. In this video, we are going to discuss the Terengganu paper 2. Let's start. First, we look into the section A, the 8 structure questions. Diagram shows the structure formula of two different types of rubber, so rubber X and rubber Y. So in our syllabus, we know it has vulcanized and unvulcanized rubber. So vulcanized rubber, it has the sulfur linkage. So here it's very easy to recognize. If you see the sulfur links, right, like this, so we know this is the vulcanized rubber. Without sulfur links, there will be the unvulcanized rubber. So state the type of rubber X and Y. So X should be unvulcanized rubber, so Y should be vulcanized rubber. So state one example of the product made from the rubber Y, so vulcanized rubber. Actually quite a lot of the example here, like tires or shoe soles. Okay, you can choose any one of here. Okay, now when the rubber X is heated with sulfur, rubber Y is produced. Name the process. So this is called vulcanization. Vulcanization. State one difference characteristics between the rubber X and rubber Y. Okay, you can choose any one. So rubber Y is more elastic than rubber X, or it is harder, or it is more resistant to heat. Okay, for vulcanized rubber. Question number 2 regarding the periodic table. So you are given A, B, C, D, E, F. Okay, given in the periodic table. Okay, now A, D, F are in the same group. Okay, then B, E, and C are different groups. Okay, what is the basic principle used to arrange the elements in the periodic table of elements? So how do we arrange the periodic table for the elements? So it's ascending order or increasing of the proton numbers of the elements. Now state two elements that are placed in the same group. Okay, just now we mentioned already there are three, so you can choose A and D, A and F, or D and F. Okay, they are from the same group. Write the electron arrangement for atom B. Okay, so it's 2 6, 2 6. Now atom E, atomic size of E is smaller than atomic size of D. Okay, so atomic size actually is determined by the electron shells occupied with electrons. So if E is smaller, meaning that the number of protons of the E is smaller than D. So attraction force of nucleus towards the electrons of the E is stronger. This is from the same period. They have the same electron shells occupied with electrons, but E, it has more protons. So if more proton means the nuclear attraction or attraction force between the nucleus to the electrons is stronger. So it can pull the electrons closer to the nucleus, so the size will be smaller. Now question number 3. Table shows the empirical formula and molecular formula of two compounds here. So state the meaning of empirical formula. So empirical formula is the simplest ratio of atoms. Okay, simplest ratio of atoms for each element in the compound. Okay. Meanwhile, for the molecular formula is the actual ratio, or actual number of the atoms. Write the empirical formula of the compound M. So compound M, so this is a molecular formula, the actual one. So we can see whether we can simplify it or not. 4 and 8. So we can simplify it by divide them in with 2, right? Okay, with 4. Okay, with 4. So becomes CH2, CH2. Now, when the compound J is heated strongly, it will decompose to form the zinc oxide, oxygen gas, and nitrogen dioxide gas. So write the chemical equation for the decomposition of the zinc nitrate. Okay, so zinc nitrate, it will decompose to form the zinc oxide, nitrogen dioxide, and oxygen. So we need to balance the equation. Times 2, 2, and this nitrogen dioxide will be 4. So it is balanced. Now if 1 mole of compound J is heated, calculate the volume of gas, nitrogen gas dioxide produced at room condition. Okay, now J is here. Volume of gas nitrogen, so nitrogen dioxide here. Okay, so we have to do the mole ratio. Okay, so 2 moles of zinc nitrate produce 4 moles of nitrogen dioxide. So if 1 mole, so 1 will be 2, 1 to 2. So volume will be 2 mole times the molar volume, so it will be 48 cubic decimeter. Okay, now question number 4. Okay, City and IU wash a shirt use the seawater. So here seawater, you should know, actually seawater, it is a hard water. Okay, hard water contains what? Calcium ions and magnesium ions. Okay, so City using the cleaning agent A while IU use the cleaning agent B. So it shows the molecular formula. Okay, so cleaning agent A, we look into the functional group. So this is the carboxylate. So we know if you see C double bond O C, C double bond O O, so it's carboxylate. So this one would be salt. Okay, and then if you see SO3, okay, all these so this one will be detergent. Okay, very easy to recognize. Now, which cleaning agent is a salt? So it's L. Now state the name of the process to making the salt. Will be saponification. Now sodium reaction between the palmitic acid in cooking oil and the sodium hydroxide is a process of making the salt. Write the chemical equation. Okay, it looks complicated. Actually, no. Okay, so sodium palmitic acid react with the sodium hydroxide. Actually, is a neutralization. So it forms a salt. Okay, and the water. So the salt will be sodium palmitate. Okay, so here we just copy down the palmitic acid with sodium hydroxide. So actually, you just need to take out the hydroxide and then the hydrogen. Okay, so hydrogen and the hydroxide combine, it forms the water. Okay, then the remaining CH3 CH2 bracket 14 COO, then Na. Okay, because the charge for the sodium is positive, positive 1. Okay, so this is a balanced chemical equation. Now, a cleaning agent diagram shows the situation 1 and 2 on the cleaning action of cleaning agent A and B on the dirty cloth in the seawater. So we look into the situation A. Okay, so the oily stains remains. Okay, but for the situation B, for the cleaning agent B, so no more. Okay, no more stains. Okay, oily stains is removed. Now based on the diagram, so which situation the cleaning agent action is less effective? Explain your answer. So 3 marks. So for less effective will be situation 1. Okay, why? Because hard water contains the calcium or magnesium ions. Then an ions of a salt reacts with calcium and or magnesium ions to produce the scum or precipitate or insoluble salt. Okay, normally we just use the scum. Okay, so this is why the situation 1, the salt is less effective. Okay. Question number 5. Diagram shows the electron arrangement of sodium chloride compound. Sodium chloride. So you can see positive and negative. So this is ionic compound. Okay. Now state the type of bond. So be ionic bond. Okay. Now how the sodium ions and chloride ions form from their respective atoms. So here, if you look into the diagrams, sodium forms a positive 1, right? So sodium ion atoms release 1 electrons to form the sodium ions. Okay, then the chloride, you see the negative 1, right? So chloride atom accept 1 electrons to form the chloride ion Cl minus. So they will attract together by strong electrostatic force. Okay, for this one is a sharing of electrons. Electron arrangement of a compound X form when the oxygen react with carbon, so they share the electrons. So state one property of the compound. So sharing of electrons, so it will be covalent compound. Covalent compound. So property, cannot conduct electricity in all states, or insoluble in water, soluble in organic solvents, low melting and boiling points. Okay, you can choose any one. Now, chemical equation shows the reaction between the compound X and ammonia to form the urea. So ammonia react with carbon dioxide forms the ammonia urea with what? With the water. So we need to balance the equation times 2. Okay. Next, if 224 cubic decimeter of gas X reacts with ammonia, calculate the mass of the urea form. So what is the mass? Okay, so given to you the gas X. So gas X is here. Okay, 24 cubic decimeter. So we find the mole 24 volume over the molar volume. So you get 1 mole. So mole ratio will be 1 to 1, right? 1, 1. Okay, so meaning that the urea also 1. So molar mass is 60 for urea in total up. Okay, given to you. So mole times the molar mass, so it's 60 gram, meaning that the mass is 60 gram is produced. Diagram 6 shows a series of reactions involve the salt W. Salt W. So have a look here. When you heat it, it will form the copper 2 oxide, brown gas, and then gas Q. Okay, if you see, you will release 2 types of salt, 2 types of gas. This one will be nitrate, no? Okay, nitrate, and then copper 2 oxide. So meaning that this one will be copper 2 nitrate. Okay, and then when the copper 2 oxide react with the solution R, okay, you will form the salt W. So salt W is nitrate. So meaning that it needs to react with the acid, nitric acid, no? Okay, nitric acid. Okay, next reaction 3. So you heat it, okay, or no, you react it with the solution S. So it forms the copper 2 carbonate is the solid, and then solution Z. So this one should be precipitation. Okay, so meaning that for this solution S, you need to choose something that contains the carbonate. So you can choose spar carbonate, sodium carbonate, potassium carbonate, or ammonium carbonate. Okay. So let's see the question. State the color of the copper 2 oxide. So what do you think? Yes, it is black color. Now the solid of copper 2 oxide can be changed to solution salt W through the reaction 2. Suggests a chemical that is suitable to change the solid copper 2 oxide to salt W. Just now we discussed already. It's a nitric acid. Nitric acid. Write the chemical equation. Okay, to represent the decomposition of salt W by the heat. So copper 2 nitrate produce copper 2 oxide, nitrogen dioxide, and oxygen gas. So 2, 2, 4. Okay, 2, 2, 4. Now state the observation when the excess ammonia solution is added to the solution of salt W. Okay, so here blue precipitate is formed. Then it dissolves in excess ammonia solution, and dark blue solution is formed. Okay, now based on the diagram, based on the reaction 3, solution S is added to solution W to produce 2 types of salt, copper 2 carbonate and Z solution. Okay, describe a chemical test to identify the ions present in the Z solution. Okay, so first we add in dilute sulfuric acid followed by 2 cubic centimeter of iron 2 sulfate solution into the test tube containing the Z solution. So this is for nitrate nitrate ions test. That is the brown ring test, followed by concentrated sulfuric acid along the wall of the test tube. Then observation, brown ring is formed. Okay. Now question number 7. Okay, diagram shows the bottle of liquid disinfection that contains the compound X. Beside the compound X, compound Y with fruity smell also found in the liquid of disinfection. Okay, now state the homologous series of compound X. So here we know it has the hydroxyl group, so it's an alcohol group. Now state the name of the compound X is ethanol. Okay, compound X is known as a clean fuel. The combustion of a compound X produce a blue flame without soot. Write the chemical equation for the combustion. So ethanol, C2H5OH plus oxygen produce a carbon dioxide in water combustion. Then we need to balance the equation. Carbon, so 2 carbon dioxide, hydrogen 5 plus 1 6, so 6, 3 times 2 6. So oxygen will be 4 plus 3 7, so here 1, so 3 times 2 6, so times 3. Okay, next compound Y with the propyl butanoate, okay, it's the ester, can be prepared through the reaction of Z between the alcohol P and compound Q. So name the reaction Z, so it's esterification. So state the Q, okay, name of the Q. So we know it is a butanoic acid, so it forms a butanoate. Propanol is from the it forms the propyl. Write the chemical equation. So propanol C3H7OH, butanoic acid will be CH3COOH. So it forms a propyl butanoate with the water. So this is a balanced chemical equation. Okay, C. During the COVID-19 pandemic, okay, usage of liquid sanitizer that contains up to 70% of the salt of the X compound is necessary to measure to prevent the spreading of the germs. Based on the medical expert, washing hands routine use the soap and water is more effective than using the liquid sanitizer. Suggest why liquid sanitizer is preferred than traditional soap and water routine. Why? Okay, so easy, volatile, cause the hand can dry easier, and then it can travel friendly, easy to bring anywhere. Okay, so this is a major reason why we like to use the hand sanitizer. Okay. Question number 8. Okay, diagram shows the apparatus to carry out the experiment to determine the heat of neutralization between the nitric acid and sodium hydroxide solution. Okay, so volume and concentration, and then this is volume and the concentration of the nitric acid. Here use the polystyrene cup. Then the temperature change, initial 28, highest temperature is 34. So we know temperature increase, so this is exothermic now. Exothermic. Now, what is the meaning of heat of neutralization in this experiment? So it's a heat release when 1 mole of water is formed from the reaction between the nitric acid and sodium hydroxide. So for this experiment, so normally we use example, so nitric acid and sodium hydroxide used in this question. Suggest one apparatus that can be used to replace the polystyrene cup. Actually, polystyrene cup is the best already, but if you don't have the polystyrene cup, you can use the plastic cup. Okay, now based on the experiment, okay, calculate the heat change in the reaction. So you use a Q equals to mc theta. So m is 25 plus 25, c is 4.2, 4.2. Okay, theta is 6, so you get the value is 1260 joule or 1.26 kilojoule. Now calculate the heat of neutralization. So we find the delta H. Before you find the delta H, you need to calculate the number of moles, right? So mole is mv over 1000. For acid and alkali are the same. Okay, so 0.025 mole. So Q is 1.26. So we can use the formula negative Q over the mole. So you get 1.26 divided by the mole 0.025. So you get negative 50.4 kilojoule per mole. Okay, so this is the answer. Okay, now if the experiment is repeated by using 25 cubic centimeter of 1 mole per cubic decimeter sulfuric acid to replace the nitric acid, meaning that now you use the sulfuric acid replace the nitric acid. What do you think? Okay, predict the value of the heat of neutralization for the reaction. So will the heat of neutralization increase? decrease or remain the same? Yes, the reaction will produce the same heat of neutralization. You'll be confused why the diprotic acid use the heat of neutralization still the same. Okay, explain your answer. Because the heat of neutralization is a heat release for formation of 1 mole of water. Okay, because sulfuric acid, if you see, you'll produce 2 moles of water. So if you divide by 2, you still can get the same heat of neutralization. Okay, now a mountain climber went to warm his hands and feet. He used a special pack that contains a chemical. Hence, the pack contains the anhydrous calcium chloride that dissolved in water release the heat of 85 kilojoule per mole. Okay, so draw the energy level diagrams to show the heat change. So here the keywords here release heat, right? So meaning that you have to know it is exothermic. Okay, exothermic, so meaning that the energy level diagrams will be like this. Okay, so we need to label the equation energy, and then the energy level for the reactants is higher than the products because heat is released to the surrounding. Then the delta H is negative 85 kilojoule per mole. Okay, so it is an exothermic reaction. Okay, in section B, we are going to discuss 2 essay questions here. Okay, but in the exam, you just need to answer any one of these questions for section B. Okay, diagram shows the 2 situations of grilling 500 grams of meat. Okay, situation A, the size of the meat is smaller, but situation B is a bigger size. So based on diagram, which situation meat will be cooked faster? So definitely is situation A. State the factor that affects the rate of cooking the meat. So it's the size, right? Size or total surface area, size of meat or total surface area of meat. Okay. Now, table shows the information about the reactants and temperature used in 3 experiments to study the factor affect the rate of reaction. This rate of reaction between the calcium carbonate and hydrochloric acid produce the gas X that makes the lime water chalky. So this gas X will be carbon dioxide, right? Okay, now we look into the experiment 1. Temperature 35. Excess calcium carbonate chips and concentration 0.5 mole per cubic decimeter. Experiment 2, temperature higher. Okay, the other are the same. Okay, also chips. Okay, then for the experiment 3, okay, also chips, but this one higher concentration. Temperature are the same with the set 2. Okay, then the time to collect 50 cubic centimeter of the gas, 50, 30 and 20. So meaning that this one is the first, followed by second, this one is the last. Okay, now what is mean by rate of reaction here is a change in the quantity of the reactants or products per unit time. So state the name of the gas produced. So this one will be carbon dioxide, carbon dioxide gas. Now write the chemical equation for the reaction between the calcium carbonate and the hydrochloric acid. Okay, so calcium carbonate with hydrochloric acid produce the calcium chloride, water and carbon dioxide. So this one is a very common chemical equation, you should know. Then calculate the maximum volume of the carbon dioxide gas produced. So what is the volume produced? So first we need to calculate the number of mole for the hydrochloric acid. Use the MV over 1000. So you'll get 0.015 mole. Okay, because the calcium carbonate is excess in the question. So mole ratio, 2 mole of hydrochloric acid produce 1 mole of carbon dioxide. So if 0.015, so it'd be half, right? 0.0075 mole of the carbon dioxide. So if we want to find the volume, mole times smaller volume, you get 0.18 cubic decimeter. Unit must be stated correctly. Okay. Now question number 3. Calculate the average rate of reaction for experiment 2. So volume 50 divided by the time 30. So 1.67 cubic centimeter per seconds. Okay, so volume divided by the time. Now compare the rate of reaction between the experiment 1 and 2, and then 2 and 3. Use the collision theory again. Experiment 1 and 2, so it is affected by the factor of temperature. So first we can mention the rate of reaction in the experiment 2 is higher than experiment 1, because the temperature of the experiment 2 is higher than experiment 1. So next point we need to explain when the temperature is higher, so the kinetic energy of the particles in the experiment 2 is higher than experiment 1. Okay, so the frequency of collisions between the hydrogen ions and the calcium carbonate in the experiment 2 is increased or is higher. Okay, then finally the frequency of effective collisions between the hydrogen ions and the calcium carbonate in experiment 2 is higher than experiment 1. Okay, so the particles, you have to mention it correctly. So calcium carbonate, we don't mention is what is the particles. Calcium carbonate is the special example here. For experiment 2 and 3, so rate of reaction in the experiment 3 is higher than experiment 2. Okay, why? Because the concentration of hydrochloric acid is higher in experiment 3 compared to experiment 2. So the number of hydrogen ions per unit volume is higher in the experiment 3 compared to experiment 2. Then point number 4 and 5 are the same. Frequency of collisions between the hydrogen ions and calcium carbonate in experiment 3 is higher. Then frequency of effective collisions, okay, are the only difference. Okay, with the point number 4. Okay, so remember, you can see point 4 and point 5. This one also point 4, point 5 are the same. Okay, just the word effective collisions. Okay. Now question number 10. Table shows the information about solution P and Q with the same concentration but different pH value. So P, pH less than 7, react with copper 2 oxide to produce copper 2 nitrate and water. Q less than 7 also react with sodium hydroxide solution to produce sodium ethanoate and water. So here we can see this one nitrate, this one ethanoate. So meaning that this one will be nitric acid. This one will be ethanoic acid, CH3COOH. Okay. Now based on the table, state the name of the solution P and Q. So P will be nitric acid, Q will be ethanoic acid. Which solution shows the higher pH value? So it will be solution Q. Why? Explain your answer. It has lower concentration of hydrogen ions because it ionizes partially, okay, in water. Okay, it's a weak acid. Now diagram shows the apparatus using the titration process. Acid and alkali. So sulfuric acid with the potassium hydroxide. Okay. Now state the type of reaction that occur. Then write the chemical equation. Calculate the molarity of the sulfuric acid is the Ma. Okay. So endpoint of the titration is 10 cubic centimeter. So this is a neutralization. Chemical equation, sulfuric acid with potassium hydroxide. So forms the salt, potassium sulfate and water. So times 2 to balance the chemical equation. So for the calculation, we use the formula MAVA over MBVB equals to A over B. So here, remember A is for acid, B for alkali. Okay, just replace in all the information. We need to find the MA. Okay, volume is 10, divide by MB 0.5, VB is 20. Over 1, A is the acid. For acid is 1, for alkali is 2. Okay, so 1 over 2. So how to find MA? So cross multiply. So we can say MA is 0.5 mole per cubic decimeter. Okay, unit must be stated correctly. Okay, C. Table shows the apparatus to investigate the electric conductivity. And one of the acid properties when hydrogen chloride dissolve in the solvent X and solvent Y. So you see, if the bulb is lights up, meaning that the solvent X should be what? Should be water. Okay, so if no reaction, the bulb is not light up. So Y should be organic solvent. Okay, organic solvents such as propanol, metabenzene. Okay, now reaction 2, hydrochloric acid in solvent X is water, so it can release the bubble gas, then it connect it to the lime water, so lime water turns to cloudy. Okay, but this one no reaction. Okay, no reaction. Oh, so this one no reaction because no hydrogen ions. Okay, now suggest the solvent X and Y. Explain the difference. Okay, so solvent X is water, solvent Y is metabenzene, propanol, and so on. Okay, choose any suitable organic solvent. Okay, now explain the difference of the observation. So in set 1, in solvent X, the bulb is light up because the hydrochloric acid ionizing water produce a freely moving ion, so it can conduct electricity. Okay, for set 2, for the solvent Y, in solvent Y, bulb does not light up. Okay, and then meaning that hydrochloric acid cannot ionize in Y to produce a freely moving ions. The hydrochloric acid exists in the molecule form, it cannot conduct electricity. Okay, meanwhile in the set 2, in solvent X, there is water, bubble gas produced because hydrochloric acid ionizing water produce hydrogen ions that can react with the calcium carbonate produce carbon dioxide. Okay, for set 2, no reaction, because no bubble gas produced, because the hydrogen chloride does not ionize in water, produce hydrogen ions. So no reaction with the calcium carbonate, and then no carbon dioxide is produced. Okay, for section C, there will be 1 compulsory answer, 1 essay questions. Okay. For question 11, okay, a group of students conduct an experiment to investigate the transfer of electrons at a distance in a redox reaction. Okay, what is mean by redox reaction? So redox, red means reduction, ox means oxidation. So chemical reaction where oxidation and reduction occur simultaneously, occur at the same time. Okay. Now you are given a list of apparatus: U-tube, connecting wire, galvanometer, carbon electrodes, bromine, water, potassium iodide, and then sulfuric acid. Okay. Now draw a label diagrams to show the apparatus to conduct the experiment. The diagram must include the apparatus and the materials given in the table. In your diagram, draw the arrow to show the direction of electrons flow. Then write the half equation for the oxidation and half equation for the reduction. Okay. So here first we need to draw the diagrams, right? So okay, so carbon electrodes is dipped into the 2 solution in the U-tube. Okay, potassium iodide solution, then bromine water. Then it is divided by the sulfuric acid. Okay, galvanometer is given. Okay, the connecting wire. Okay, so electron is flows from the anode to cathode. So anode is the iodide. Iodide undergoes oxidation, so it forms the iodine. Then bromine change to bromide, it undergoes reduction. So electrons flows from the anode to cathode. Okay, so this is the electrons flows. So half equation, so iodide ions for the oxidation, iodide ions lost 2 electrons to form the iodine. Meanwhile for the bromine is a reduction. Bromine gain 2 electrons forms the bromide ions. Okay, so if here you will see the observation, so this one will be brown solution is formed, okay, because of the iodine. And then this one bromide, okay, so brown bromine water it turns to colorless, okay, because all change to bromide ions, which is colorless. Now table shows the observation for these 2 reactions between the metal X with 2 different salt. So copper 2 sulfate salt, okay, and then zinc sulfate. This one with copper, 2-sulfate brown solid brown deposit is formed. Meanwhile for zinc is no reaction, no? So metal X can react with carbon 2 oxide but cannot react with zinc sulfate. So let's have a look here. So if X negative 0.13, copper 0.34, zinc is 0.76. So meaning that if we look into the pair here, this one is the most negative, right? Most negative. So this one becomes the highest. So zinc will be highest, followed by X. So then finally is copper. Okay. So meaning that X cannot displace the zinc, but it can displace the copper. That's why the result is like this. Okay, now based on the E0 value, okay, arrange the atoms or ions in the ascending order. Okay, so you can see, and then next explain why there is a difference in observation obtained in the table 11.2. Okay, so first in the ascending order of the oxidizing agent, so it'll be Z ions, X ions, and then the copper ions, ascending order. Or the ascending order of the reducing agent will be copper, X, and zinc. Okay. Now for set 1, okay, why the observation is like that? So E0 value of X is more negative than E0 value of copper. Okay, so X atom is easier to release the electrons as is a stronger reducing agent. Okay, but for the E0 value for the copper is more positive than E0 value of X2 positive. So it is easier to receive electrons. So copper is a strong oxidizing agent. Okay, so reaction occur for set 1. But for set 2, E0 value of X is less negative than E0 value of zinc. So it is cannot or harder to release electrons. So X is weaker reducing agent. For the zinc, more negative than X2 plus. So it is harder to receive electrons. So it is a weaker oxidizing agent. Okay, so reaction not occur. So that's why no reaction for set 2. Now see, a student carry out an experiment to study one of the factors affecting the electrolysis. It shows the observation for 2 sets of experiments. Both experiments use the carbon electrodes. So set 1, at the cathode, colorless bubble gas, anode, greenish yellow bubble gas. For set 2, colorless gas, set anode also colorless bubble gas release. Okay, so by using the suitable electrolyte, describe an experiment to carry out to obtain the observation. So pour the beaker until half full, or electrolytic cell until half full with 1 mole per cubic decimeter hydrochloric acid, or concentrated hydrochloric acid. Okay, or any suitable soluble chloride salt solution also can be accepted, but reject the ammonium chloride or copper 2 chloride. Then dip the carbon electrode into the beaker or fill 2 test tubes with hydrochloric acid and invert in on top of the carbon electrodes in the electrolytic cell. Then connect the carbon electrodes to the switch and battery with the connecting wire, and then repeat step 1 to 3 using the dilute hydrochloric acid. So here, example 0.001 mole per cubic decimeter of the hydrochloric acid. So explain why there are differences in observation in the anode, given to you the E0. Okay, so for set 1, chlorine gas is released because chloride ions is discharged because the concentration of the chloride ions is higher than hydroxide ions. Okay, meanwhile for the set 2 is the oxygen gas is released because the hydroxide ions is discharged. Why? Because the E0 value of the hydroxide ions is more negative or less positive than E0 value of the chloride ions. Okay, so that's all for the Terengganu paper 2 trial papers 2021. Like this video share this video with your friends. Thank you.